What is namespaces, hmi-bind, and how to use it? How to dynamically change widget attributes such as color, coordinates, opacity? The answer to this and other questions in this video. Welcome back. My name is Cyril and I am Controls Engineer. Today we will take a deep dive into what hmi-bind is. You can repeat the whole process with me to fully understand, because right now I will create a simple widget that will show you the whole process. I'll create a svghmi file here by hand, without copying anything from elsewhere, so you can easily replicate it all along the process. Let's go. Let's create a new file. I'll call it test_rectangle.svghmi. An empty file appears. Open the first tag, svg. Here appears a tooltip. Okay, the minimum structure created. And as you can see here, we have this attribute xml_ns. I want to go into detail about this because it's an important point. For WinCC unified widgets, we need to connect at least two namespaces. What is namespace? The namespace is a special prefix which is implied by the XML standard. It is needed to extend the functionality and possibilities of XML. An SVG is a special case of XML standard. The syntax, the opening and closing tags, and the presence of attributes. But in the case of Siemens and WinCC Unified, we need to declare two namespaces. I will remove this one. Namespaces are written with the prefix xml_ns:, and the name of namespace. The first namespace we need to connect is the hmi. Let's add it. xml_ns:, hmi. And it needs to be assigned a URL, by which the subsequent program, in our case WinCC Unified, then understands how to work with it. Here we need to write the following: http svg.siemens.com hmi. The second namespace we use, which is actually in the title of this video, it is hmi-bind. It is written as follows: xml_ns:, hmi-bind equals http svg siemens.com hmi-bind. Also, minimally, we need to add the viewBox attribute. The viewBox is the area where our widget will be visible. I'll create an area of 100 by 100 pixels, and it will start with a point 00. I type in 00, 100, 100. Well, to see all the changes that I will do in the file, I will turn on the SVG Preview plugin. Right click on the file and select SVG Preview. Here in this area will be visible SVG file. To make it work for you like me, you will need to do some VSCode adjustments. You need to add an association of SVG HMI files with the SVG format. Let's do it. Open File, Preferences, Settings, and search for File Associations. I made a mistake somewhere, but it already offers it to us. I have it already filled here, but you need to add a new line, where in the key field specify an *svghmi, and in the value field specify svg. If you do this, VSCode will associate all files with extension svghmi with svg type. So you will have a svg preview and right mouse click formatting of the document, and you will work much faster and more comfortably. So now let's create an svg. I'll add 2 squares. The first one with dimensions of 100 by 100. I'll change the color and make it gray. And the second square with dimensions 50 by 50 and green color, for example. As you see, it will not show up, because for SVG is very important the order of elements. Elements that are below in the file are displayed as if on top. But right now the green square is under the gray one, and you can see it. You have to move it down in order for it to show up. Like this. You can see it now. I'll set it coordinates so that it's centered, for example. And now a few words about the SVG coordinate grid. The origin of the coordinates is in the upper left corner. This is the point with coordinates 0, 0. X coordinate counts from left to right, but the Y is from top to bottom. I'll show you an example. Setting X coordinate to 10, the square is shifted to the right. 20 is still shifted. 25, and it is in the center, because the width of the square is 50. 25, this is the coordinate of the location of its top left corner. Accordingly, it is in the center. This leaves us with 25 pixels to the left and 25 to the right. It is the same with the Y coordinate. This point will be here, and a square will be drawn from it. Well, in order to make our widget syntactically correct, we need to add a header section. And here we use the first namespace that we connected earlier. It looks like this. HMI self. We'll close this tag right away. And we need to specify the mandatory attributes in it, such as display name. That's what name will be displayed widget. I will specify it the same as the file name. By the way, I made a 2 points the file name. Let's fix it. The next attribute, name, is a system name. For some reason, it always comes with prefix, extended. I stick to the same naming principle. Then the attribute performance class with the value L. And the widget version. If I save this file now and try to edit in WinCC, we'll get an error. I refresh the widgets And here we see the following. Value cannot be null. This message tells us that we must have at least one interface parameter. We have to create inside of the self param_def element. It must also belong to the hmi namespace. Let's name it, for example, just color. Type hmi color. And default value. Let it be black. Save and try to update the widgets in WinCC Unified. WinCC still complain. I must be wrong somewhere. Oh, sorry, I forgot to add attribute type. Type equals widget. Now everything should work. Yes, here it is test rectangle appeared. You can pull it on the field and see that it has one interface variable color. Let us move on. Now let's finally learn how to use hmi-bind. hmi-bind allows you to bind an interface variable to some attribute for an element and dynamically change value of this attribute. I'm going to start with a coordinate. I'm going to bind x and y coordinates to an interface parameter and dynamically change the position of the green square. Let's give it a more appropriate name instead of color. Let's call it position, so it will reflect the essence of what we are doing. And we will need number instead of hmi color in type field. We should also change the default value, 25 for example, as current coordinate, and in order to bind x to this variable, we need to add an hmi-bind prefix before x with a colon. As you can see, as soon as we did this, the previewer moved the square to 0 point, as if the x coordinate was not set. And technically it is, because we changed the x attribute to hmi-bind colon x. Consequently, the previewer doesn't know what to do with such an attribute and skips it. To make it work, we need to change the assignment value as well. We must specify that we want to get the value of the coordinate from the position variable. This is done as follows. We delete 25, we leave the quotes, double curly brackets should be added inside them. Inside these double quotes, we can now write pseudocode and even some logic, but more about that later. Let's start with a simple one. Let's directly set the position variable here. The syntax is as follows: param props dot position. Param props means the section of interface variables. That is, when WinCC displays the widget, it will parse the code of svghmi and substitute the current value of the position variable in this place. Let's see how it works in WinCC. Update. Drag and drop onto the screen. Let's try to change the value. Here is how it works. We can dynamically change the x coordinate. Let's try different values. 10, 20, 50. The square is at the very edge. Can go on 60, 80. So we can see that we are not limited to anything. The square can go beyond the widget's field of vision. It is the same with negative values. We can specify -20. We can see that it has gone out of the bounds to the left. We will deal with this problem in just a minute. For now, let's bind the y coordinate to the position variable. It can be simply copied from here. And add hmi-bind prefix. So delete widget, close screen, refresh. It's already visible that its location in preview has changed. Change it to 0. Now we can see that everything works. The square has moved to the top left corner. It means that x and y coordinates are changed at the same time. We set 50 to move it to the bottom corner. Great. But the current approach is not convenient. We should remember that the maximum value we can set is 50. Plus, you can set such a value that the square will go out of the field altogether. Generally, it would be nice to limit object movement on the field and unify the position variable. For example, we should not set coordinate value, but we should set it as a percentage of the maximum, where 100% would be positioned at the lower right corner and 0 at the upper left corner. Siemens has a special function for this, limiter, which limits the input value. Let's see how it works. For convenience, we will create a local variable. The writing syntax is similar to the interface variables, but we need to put them in the def section, and there are a couple of differences. Under the HMI self section, we will add a def section and put our local variable in it. In the same way with prefix hmi, we write local def. Then name normalized value, type, and instead of defaults will be value. Right here we calculate new value for coordinate. Here's how it looks like. Double curly braces, Converter.Bounds. This function bounds the input value to the top and bottom. It takes 3 parameters as input: value itself, then the minimum threshold will be 0 and the maximum value will be 1. We decided that the position variable will change the position in percent from 0 to 100, but we will divide this number by 100 for convenience. In other words, 100% will be equal to 1. It will become clear later. And now we need to change the entry in the x and y attributes. Let's change param props to local props. And change position to normalized value. But we remember that our normalized value changes from 0 to 1. But in this place we want the coordinate change to 50 pixels. So we just need to multiply the normalized value by 50, like this. That is, once again, these little calculations will make it so that 100% equals 50 pixels. 50 is this coordinate that corresponds for the extreme position of the square, and the square won't go beyond the gray area. Okay, we can copy this expression to y. Let's check how it works for WinCC. I delete the widget, close the screen, update widgets. That's how we get the error. I show the whole process of widget creation on purpose, because we are not robots and we can make mistakes. The main thing is to be able to find and fix them. Yes, I misprinted here, position. Save and return to WinCC. And then you don't have to close the screen. Here is the widget. You see that our value is 25, but the square is not in the center of the field. Set it to 0. That's right. Try 100%. Also correct. The square has moved to its extreme position. Let's try going beyond, like 110%. As you can see, the square stayed in its extreme position and did not go out of bounds. This is why the function Converter.Bounds will work here. This also works as 150 and 200. Everything works correctly. Great. The same thing happens when I specify a negative value. For example, minus 200. Less than 0 coordinate, square doesn't go. Perfect. Let's move on. I'm going to format the line breaks a bit, because it's already not very convenient. Next, I want to show you how to work with color. I have already done that in previous videos, but I want to go over it again. By the way, if you like this or other videos, you can subscribe to my channel and then you'll know when there is a new one coming out. Plus it will promote the channel and I'll know I'm doing useful and relevant content and will try to release more and more frequent new videos. Return back to color. I will add a new variable. hmi-param def name color, for example. Type hmi color, default, let it be green. There is a nuance here with color. The color is not specified via hash as usual in SVG, but after 0x. Here we have 4 values. First value is alpha channel, that is responsible for transparency. FF means the maximum visibility. Red channel set to 0, green channel FF, blue channel 0. And now we will bind this variable to the field fill. We write hmi-bind according to an understandable scheme. You see it is immediately black, because this is the default value for fill attribute. Change the value to expression in double curly braces. If we print param_props.color directly here, it won't work. We won't get what we want. That is why we cannot pass directly value of hmi-color type into fill attribute. It must be converted into a usable format for SVG. Siemens has a function for that, which is also located in the Converter section. It is called RGBA. Now the color will be properly changed and displayed. Delete object, close screen, refresh. Here in the preview the square is now black too. That means we have most likely done everything correctly. And here the color is green as it should be. We change the color and everything is correct. Let's do one more thing. Let's control the transparency. Add one more variable, hmi-param-def, name, opacity for example, type, number, default, 100%. Let's add a local variable. hmi local def, name, let it be local opacity. Oops, I just now noticed a surprising thing. The normalized value variable has the data type specified with the word type. This is a total nonsense, but it works at the same time. Frankly speaking, it's a revelation for me. It is unclear why there is no error and how it works. Yeah, alright. I'll let it be. I'll have to test it later in what situations it might still work or not. Alright, back to transparency. Let's copy the value from normalized value. We'll use the same approach, because we set the opacity attribute to values from 0, which corresponds to full transparency, to 1. We add a new attribute hmi-bind, opacity, equal, and in double curly braces, local props dot local opacity. Leave it like that because we need a value between 0 and 1. I'll fix here for number. I can't look at it. It's not right. Saving. Updating the widgets. Here's our new opacity parameter. Set it at 50%, half the visibility. You can see that it's pale. 20%, even harder. And 0 is invisible altogether. Well, everything works. Here are the basic ways of using hmi-bind that I wanted to show you. Subscribe to my channel and be the first to see videos about WinCC Unified and industrial automation.